developing national guidelines for dredge disposal at sea, where it's kind of two components. One is we're trying to help Environment Canada understand the oceanography of their existing sites, as well as help them develop guidelines that they can give to proponents that would like to propose new disposal at sea sites. I've left the abstract in there just for people who might be interested to come back later on the video. The project is led by me at the Geological Survey of Canada and Roanna Leung at Environment and Climate Change Canada. And I should say that we had a consultant this year, Pauline Martins, and I wish I'd put her name in here because she did a lot of the work that's coming in this talk. Anyway, it's been a great project. A few years now. It's sort of low stress, well-defined outputs, and practical. And we share ships, we share equipment, we share staff, and we share funds with Environment Canada. So here's the disposal sites on the west coast of Canada. You can see that they're mostly concentrated down near where the sort of larger cities are, of Vancouver and Vancouver Island, one up in Prince Rupert. But even this one is actually something like 50 nautical miles off the coast of Prince Rupert. So it's not really that easy for dredge ships to get to. It takes them hours. There's no option for kind of hydraulic pipe sort of dredge disposal up in this area. So the proponents are requesting new disposal sites, especially in this area here of Douglas Channel, where, of course, some of our largest ports are currently being constructed, and there's no official disposal at sea site. The thing is, when proponents make a license request, they submit the sort of oceanography, the science of the area, and it really has varied in quality. And those of us reviewing it decided that we really need to provide guidelines to these companies so that they know what we're expecting to see in these documents. Canada regulates disposal at sea through a permit system. That's what that says. We also release all of our information to fulfill our international obligation under the London Convention and the London Protocol. A permit really should provide the site characteristics to be quantitative, which then helps Environment Canada determine what kind of material can be dumped there. If it's a site where currents are going to spread the stuff all over the place, then it's obviously not a place for putting contaminated material, for instance. And a permit, and the specific work that we're doing here, a permit should determine whether the proposed disposal site is considered to be non-dispersive, that is, the sediment sort of stays there over time, or if it's dispersive, which means the sediment are moving elsewhere over time. And for that, we're using a peak bottom current speed of 25 centimeters per second. Less than that, it's considered that the sediment will stay there. Greater than that, it's considered that they will move. And we're testing this definition because it's one we found in the literature. It's sort of untested for our specific areas. This year, we were testing all of this off of Point Grey in Vancouver. This is where the tankers all line up and anchor for getting into the ports of Vancouver and the Delta Port down south here. You can see that the bathymetry, or the seabed here, there's kind of it's in a trough, essentially. There's a bank to the west here, and the coastline of the University of British Columbia here to the right. There's a number of techniques we can use to determine whether an area is dispersive or non-dispersive. Does sediment stay there or does it move? And I won't get into the details of these. This is a previous site that we did. And here's another technique. So this is using multi-beam and multi-beam backscatter from our oceanographic ships. This is using coring and then laboratory dating of the sort of core sediments. And of course, this also requires a pretty sophisticated setup. You can't just core off of a small vessel. And so those both require kind of an oceanographic research ship and labs and et cetera. Another technique that's often submitted to us is hydrodynamic modeling. And here's an example of a model that was sent to us. The blue indicate the model results, the red indicate the measured results. And although it looks kind of close, when you examine it more closely, you can see that the blue overestimates most of the time the current speeds, except for the times when current speeds are sort of exceptional, then the blue underestimates. And those are the times when sediment really are going to move. At one of those exceptional times, the model data got the directions wrong. So we have kind of a westward direction and would expect sediment to be transported in a westward direction here. Now, I'm not saying this model is actually quite good, but it doesn't get it right. And the main problem here was that this model is based on data that were collected just at 1 month of the year during summer. And really that has no bearing on what happens in this area during winter when there's winter storms come sort of plowing through here. So our goal here is to design experiments which can give actual measurements of currents and sediment transport. And so we can use our oceanographic research ships and our sophisticated equipment to determine what these definitions and criteria should be. Here we have, for instance, an expensive acoustic Doppler current profiler instrument. And within its measurements, we also have an inexpensive instrument inside this tube, measuring kind of the same thing. And so here we're testing whether we can use just this instrument and get pretty much the same result as if we have this very sophisticated setup. And we need to monitor over all of the seasons. I don't think there's any justification for saying, well, we measured in the summer and we calibrated the model to that, and now we can justify the winter model. That's not acceptable. But most of all, we need to be able to transfer what we've learned over to a proponent in an inexpensive form. We can't expect them to have a ship and all of this sophisticated equipment. So we expect them to provide us some data that we've kind of predefined for them. And during this, we're also testing this this threshold that we found in the literature of 25 centimeters per second. Last year, we deployed on in Point Grey, just off the coast of Vancouver, as I said, and it was Halloween Day, so we decorated accordingly. And again, we have a big research ship to do all of this. The results indicate that currents are less than the 25 centimeters per second for tens of thousands of samples of the year, and greater than just for a few samples throughout the year. So therefore, this is defined as a non-dispersive site. However, this is where we kind of test this theory a little further. Throughout the year, you can see from the backscatter of the water column that, in fact, there's sort of higher weeks, and there's even a few kind of spikes in these sediment concentrations near the bottom. So what's causing that? Is that resuspension of sediment and it's being transported elsewhere, or is that sort of sediment from the plume of the Fraser River nearby, or are these actual disposal events taking place. So anyway, the report kind of examines all of these in close detail. And most years, all years, we write a report to Environment Canada to indicate to them the oceanography of their of one different site each year. We provide guidance to proponents through a kind of gray literature on what's expected through their disposal at sea sites. And this year, it was very exciting to me that we actually contributed to the London Convention and Protocols. I did my master's in marine protection, and that's a big deal. So that was exciting for us. If you have any further questions, please contact me. Thanks.